So good afternoon, everybody. We are incredibly humbled. You've seen that on our LinkedIn post as well. So we have about 117 registered attendees from 89 companies, 21 countries, and we're just incredibly excited to have this session, especially for our second session. That's just incredibly humbling for us. So this just validates our mission, Ventry's mission towards the renewable sector, which is making stocks and spare parts management smarter and leaner. So with that, I would just like to share a little bit for everyone to talk, just to give a bit of background on who's dialing in from where. So to our surprise, nearly 50%, so in the high 40s, they are dialing in from the US. So for those of you dialing in from the US or particularly Japan, Australia, I know it's late and we really appreciate your time. From the type of companies for the PV sector, we see that the O&M business represents a pretty significant chunk of the attendees today. But we also see that asset management and O&M businesses, which is combined asset management and operations, they do represent a significant chunk overall of the business. So, and that just makes a lot of sense because a big chunk of our focus for our presentation today is going to be an owner and an operator perspective. Nonetheless, we also see quite a lot of interest from logistics, advisory, and monitoring systems companies, as we do see them playing a significant role in advising and working with their customers in building an overall leaner and a much more efficient supply chain strategy for their businesses. So, so with regards to the presentation today, we're going to be focusing, as we said, on the owner and the operator perspective. Then I'll be briefly talking about Ventry and what we do from our solution perspective, and then we go into a Q&A. The expectation, of course, is to finish the presentation within the hour. However, if we do run over, I would really appreciate for those of you that can stick around and engage in the Q&A sessions, which will be later on in the session. So let's get cracking. Tim, over to you.
Okay, thanks. For those of you who didn't hear me last time, I'm Tim Harman. I'm an engineer with about 30 years project management experience. The last 15 years has been in the solar energy space. I've been very fortunate to work on mega solar projects in Australia and Japan, as well as for non-profit organizations working in Africa, putting solar modules on rooftops. So I've got a kind of broad experience across the whole project lifestyle. Today I'm going to talk about digitalization of spare parts management from an owner's perspective. Josh will take over from the other side. First slide. So this is pretty much what every asset owner wants to see. Really a very simple dashboard that says they've got maximum availability, high reliability, and as low an OPEX cost as possible. Next slide.
Oops, sorry about that.
I kind of see this, if you're a project manager, you know about triple constraints. Can you just go back?
Sorry about that. Is that better, Tim?
Yep, I can see that now, yeah. So asset managers on the call will be familiar with juggling this triple constraint. To maximize ROI, you've got to balance the cost of maintenance against the impact on availability and reliability. We could spend the whole talk just discussing this particular aspect, but typically the approach we see is reducing OPEX cost to reduce maintenance, either preventative maintenance or preventative maintenance. And there's been some impressive big studies. Can we stay on that slide yet?
No, I'm sorry, I'm just having some issues.
Okay. There's been some impressive big data studies suggesting that, like, for example, large percentages of inverter failure actually came down to random causes. And also the impact of doing too much maintenance can have an effect on availability because the act of repairing equipment actually doesn't help maintain it in the longer term. So to move forward, we need a different perspective, and digitalization provides, I think, this shift. Next slide. So CMS, in the past 20 years, we've seen a growth in the number of CMS systems that are coming into play. Systems have been gaining ground. They've moved from kind of large exclusive enterprise-based systems like IBM Maximo down to cloud-based solutions largely accessed by a smartphone, for example. And the CMS promised to help improve efficiency and reduce maintenance costs without compromising too much on maintenance activities. In some areas, this has proved very successful. For example, work orders are pretty much universally managed from a CMS in some shape or form, as is incident reporting. However, the information isn't clearly stored. It's not necessarily joined up. So an incident report doesn't necessarily tie back to the actual physical asset on the ground. It's just a note. There isn't any direct link back to spare parts. Next slide. So the CMMS should have been the backbone of asset management system with an asset register, keeping about asset performance, reporting, analyzing and auditing, work order management, preventative, corrective maintenance, materials and inventory management. All these things should be contained in our asset management system. But what we find is reality is, click, there are gaps in the information. And this is where a good example is the spare parts inventory, which can be something that appears in the monthly reports. It can be a PDF document, but the actual contents of the spare parts that don't physically appear as items on the CMMS system. So it's still very much local information. Next, click. So a digital system that's still working with analog information. Next slide, please. So if we look at our PV plant, this typical PV plant, and what we see here is it's still largely maintained by patrols and visual inspection. So it's very much a boots on the ground approach, not taking advantage of some of the digital technology it's been around for the past 10, 20 years. It's just it's been quite slow to implement in the solar space. Next slide. And so what we see is what I think of as islands of information. So this is a fleet. We have 3 PV plants in this fleet. And typically there's be a container on site, and in that container will be the spare parts for that site. The asset manager doesn't have a holistic view of all the spare parts. If there's a problem with an item on the plant, the spare part, the technician may go to the container, see if the spare part's in there. If it's not in the container, he's going to speak to the manufacturer, get hold of the spare parts. Some of these spare parts can be 2 to 3 months lead time. We haven't got the intelligence built into the system to properly manage the spare parts. We're also not necessarily keeping the correct spare parts. So in some projects, there might be 3 kilometers of 6mm cable, for example. 6mm cable is something I can go on Amazon and have it delivered tomorrow. I don't need to take up warehouse space with keeping cable or MC4 connectors or some of this basic stuff. Whereas other components can have a 2 to 3 month lead time. This is the intelligence that we need to somehow put into our spare parts system. So currently we have these silos of information, and the next question really is, click, is how do we link all this information? How do we start to get some more value out of this data? Next slide. Then the process, this is digitization. So digitization is, as we all know, it's the conversion of analog data. Like can be, if you take a photograph, you're converting a photograph into a digital information. If you scan a document, you're digitizing it. But it isn't necessarily digitalized information until those lines of data are actually in the computer system. It's not enough to have a PDF reference inside your CMMS. What you really want inside the CMMS is line items for all the spare parts and where those spare parts belong. Next slide. So digitalization is very much the connecting of data and the automation of that process. So we can have a unified data set, and then we can move towards condition-based maintenance and predictive maintenance. And this is where we can see some more changes in efficiency, and we can see some definite cost savings. Final click. And this is the transformation process, the data-informed decisions, sharing and collaboration. supplier unification, and paperless transactions. And from an owner point of view, the interface into your O&M provider becomes almost seamless. Rather than passing on packets information, you're kind of passing on a baton of information. Everything is contained. They can respond much quickly. Next slide, please. So if we just take spare parts, going back to our spare parts, because that's what we're talking about. Typically on my container, I'll have 3 bits of information: the part, the inventory number, how many I have, and the store, the location. That also can be local information. Maybe on the CMMS it just says that they're on a container on the site. It doesn't necessarily tell me whereabouts they are in that container, or if there's 2 containers, which containers they are. We rely on the plant manager to have that information. Click. One click. Maybe that information has been transferred to the CMMS, and maybe that information is in an analog digital format like a PDF, Excel, a JPEG, or a Word document. Click. But the reality is, associated with that that single item of inventory is a lot more information. Josh is going to talk about this in more detail and some of the importance about it. Like, just very quickly, the manufacturer, how long does it take to manufacture that part? Is it a single spare part? Is it a custom spare part? Is it in the same country? All these import items are really important to the O&M provider. And as I say, Josh will cover this in a lot more detail later. Next slide. So what we really want is this digitalized solution where we capture all of this information within our CMMS system or within our application. And the other thing to bear in mind that these spare parts, some of them have got to be there for 30 years. Some of the spare parts we're buying just in case, we might never need them. And some of them we might need on a regular basis. And therefore we have to look at where are we actually keeping those spare parts. Next slide. And the final part of this is we have to link that information because we're now in the digital world. So works orders need to be linked back to the spare parts, and asset management needs to be linked back. So you can see in this digitalized model, we've gone from having analog information just stored as documents to having a fully integrated system. And this is, I'm going to talk about condition-based maintenance very briefly, and this is an Aston Martin. It's a £3.5 million worth of kit. It needs to be maintained the same as a PV plant, but it's a little bit more interesting to look at in case you're getting bored with assets. And so I'm going to talk about the tyres on this car. So if I speak to the manufacturer, they're going to say to me, Tim, your Aston Martin, the tyres need to be replaced every 2 years or every 20,000 miles. That's an expensive piece of tyre that I need to replace. If I take a condition-based maintenance approach, I get myself a tyre gauge and I know I need to change those tyres when the tread is only 3 millimeters. And this is what we can do with asset management as well. By doing condition-based maintenance, because we've captured digital information, we can make sure that we're replacing the parts when they need replacing rather than just when the manufacturer suggests we need to replace those parts. And part of the motivation for the manufacturers, they make money out of selling parts. So they want to encourage a degree of paranoia and say these components need to be placed every 3 years, whether they've been used or not. Condition-based maintenance allows us to use technology and digital information to manage our parts so that we don't jeopardize the productivity, we don't jeopardize the quality of the plant, but we can manage the whole spare parts more efficiently. Next slide, please. So if I take a real life spare part, this is a cooling fan out of an inverter. The recommendation from the manufacturers that we replace these every 5 years. The manufacturer first doesn't actually make this particular spare part. It's made by another company called Delta. If I look on the Delta website and look at the application, it says that their life expectancy is 80,000 hours of continuous operation. So if I just say, okay, let's assume that that fan is going to work 24 hours a day, which it won't, then that still gives me a life of 9 years. So I'm replacing it actually 4 years before it needs to be replaced. Conditional maintenance and digitalization would mean that by collecting information about the temperature and any strange noises about that fan and feeding into my computer and computer system, I can actually predict more accurately what's happening to that fan. I can also then apply that across my whole fleet. So if I find this particular Delta fan is unreliable, I can step back and I can look at my whole fleet and I can say, wow, I've got that Delta fan installed in these plants as well. I need to watch that and see what's happening. Without this connection of information, I get a fan, an inverter overheats, loses productivity in one location. I can't necessarily predict where that's going to happen elsewhere. So having this digital information opens doors to predictive maintenance and condition-based maintenance, which is a far more effective and cost-effective way of maintaining a plant. Next slide. And so the digitalization of asset management encompasses all elements of the asset management process: scheduling of work, spare parts management, condition-based maintenance, predictive maintenance, which is identifying imminent failures, also estimated mean time between failures. Mean time between failures enables us to look at a particular component and see, is it actually performing well? How often does it fail? And how can I predict that model across my whole fleet? We can look at things like serial defects, identifying trends and behavioral patterns in assets. And of course, we can look at digitalization of spare parts management. And on that level, I'm going to hand over to Josh, who's going to take over now and talk about that last aspect.
Thanks, Tim. For those who don't know me, I've been in the industry about 16 years, started out as a technician, been with Wilson, spent about 10 years at First Solar, watching them climb from 800 kilowatts under management to, I think we left and joined NovaSource at close to 12 gigawatts. And at NovaSource, I'm taking on the product and strategy, directive for supply chain. So we'll talk a little bit about that, a little bit about NovaSource for those who aren't familiar, and then also dive into some of the details from an O&M's or operator's point of view. Next slide. So a little bit about NovaSource. Today we're servicing about 18 gigawatts globally, the largest independent O&M provider, and we offer a full suite of services. The core of that being, boots on the ground, operation maintenance, but we're, seeing a lot more products being developed and delivered that touch the O&M space, such as repowering, asset restoration, and supply chain solutions. Next slide. Globally, we're still fairly heavy in the US in terms of our gigawatts, but as you can see, we have a global footprint. This provides a unique challenge in the spare parts world. It is a global supply chain, very true, but if the part isn't locally available, the technicians can't keep the assets up and running, can't repair the assets. It's wasted wrench time. Next slide. So our approach from a supply chain solutions is right parts, right time, right quantity in the most cost-effective way. We've really, and we'll get into some of our warehousing strategies, our phasing of it, our learnings, but we really do a lot of central warehousing to share and distribute parts that are common amongst our fleets. It makes our inventory management a lot simpler at scale. Again, at 18 gigawatts, we have a lot of spare parts. And we handle the warehousing logistics, last mile down to the site. So what this all means to us is we can lower our cost by centralizing centralizing spare parts in our warehouse. We have less parts being found to be missing when we do that. There's always going to be a point in which we need some parts at a site. Next slide. And we can go next slide. So phase one of our learning, and this was really at First Solar, and I think a lot of O&Ms are doing the same thing, is we would use a hub spoke style setup. A hub site, which would be a larger site in the area, maybe with an O&M building or a number of connexes, could be the central point for inventory to be shipped directly from the vendors. That site was manned, and that's why it was picked as the hub site, so we could actually receive the deliveries there. And the hub site would then deliver portions of its inventory to the spoke sites. So spoke sites would have all their inventory shipped to the hub site because spoke sites were usually unmanned, not manned 24 hours a day, not manned every day of the week. So getting deliveries to those sites proves to be very difficult. Now, this worked for a number of years, but as we scaled, we found that even this was straining our technician wrench time at the hub sites. So we implemented phase 2 of our learning, in which we simply added in distribution, central warehousing. So we would have a warehouse technician that could receive the majority of our inventory and ship it out to the hub sites and so on and so forth when that inventory was needed. Now that reduced the amount of cycle counts that the technicians at the hub sites would have to do, and also enabled us from the central distribution to directly ship to spoke sites if needs be. You know, we had more control on the last mile. We weren't relying on the vendors for that, so we could, you know, ship pallets to spoke sites. Again, increasing technician wrench time because they're not having to deal with the last mile logistics. Now you can supplement hub sites for what we call forward staging. Just for example, a central warehouse may be 30,000 square feet in size. A forward staging warehouse may be, you know, 1,500 to 2,000 square feet. It can hold like a hub site. It can receive inventory and ship it out the last mile in areas where we don't have, or you may not have, a large site that's manned all the time to receive those shipments. You know, before we talk about digitization, we have to talk about physical inventory controls. I have seen some very beautiful binning architectures in Connex boxes. I've seen bins down to the actual container on the shelf. And for those who aren't familiar with bins, this is kind of like a digital storeroom within a store, or area within a storeroom. What I like to say is that you build your binning and your warehouse mapping to fit your operations. I like to tell technicians and the supply chain that it's about getting on target or close to the target, not necessarily on the bullseye. So, you know, if you have a Connex box that's full of pallets, you may just have 2 bins in that, the right and left side of the Connex box. If you have a Connex box with some shelving, you might create a few more bins for the shelves, but keep it simple, keep it manageable, because that's going to drive your cycle count efficiency. The other parts of this,
I'm sorry about that, Josh.
That's all right. We'll get into the other parts of this. Really, you know, other than the warehouse mapping, would be your timely consumptions equals timely reorders. We use a demand planning system, and if we can't see the consumptions being done real time or as close to real time as we can get, our reorder points that are set upon mid-max lead times, historical price points, and you know, reorder point EOQs, we're going to be off the mark. We're not going to be able to get the inventory ordered in the right time frame to restock. Next slide. So all this is fantastic, but it doesn't work without digital inventory. So from a digital inventory perspective, and we've looked at many solutions throughout the years, tried many solutions, you know, these are the musts in our mind. It has to be intuitive for the field personnel and clients. If clients are, you know, we don't own any of the sites we operate, so there's always someone else who is interested in their inventory that we're storing for them. You know, the solution that we pick has to be easy for them to go find their inventory and do their own internal audits of our operations, and for you know, losing inventory without consumption against a work order. The solution has to be able to work offline. So you're going to have, you know, 2 sets of people looking at this and using it. Those that are office-based that are going to have internet connections, and those in the field. And we can't always guarantee that we're going to have internet connection into the field. So the solution has to be able to work offline for the technicians. It has to be connected in with the enterprise systems. So the ERP system, the WMS system, or the warehouse management system, and the CMMS system. The user interface has to be able to connect with all of them. We have yet to find a single solution. I think, as Tim said, you know, there's many iterations, many players that have come into the market, but not all of them are doing, you know, doing it right. Not all of them have the features to do everything we want. So the user interface has to be able to connect with every part of our enterprise. And Most importantly, scalability and flexibility. Your operations are going to change as you scale, just as we did from our phase 1 to phase 2 learning of our distribution strategies. The solution that you pick, the solution that you use, has to be able to be flexible enough to change with you. And I think this is really cool that we can get to this point, but necessary is you have to be able to track the status of the spare part. It's not just about knowing if you have a spare part available or not. And you have to know if it's a new part. Are you returning the part for refurbishment or RMA, or is it a damaged part to repair? We're doing a lot more refurbishments in the solar space, and that damage to repair is a key marker. We have to be able to pull the inventory or the spare part out of the unit, put it into inventory to damage repair, and track it all the way back to refurbished or new.
Thanks, Josh. That was really interesting. There are a few questions that had come in via email, so I'm just hold those questions until we finish the last deck. In the meantime, I would just like to urge the participants on the call as well. If you have questions, there is a chat box. So if there are questions coming in, please just feel free to put them in there. And I will ask Josh, or actually I'm sharing my screen so everybody can see those questions coming in as well. All right, so basically, so we've gone through the owner and the operator perspective. I think one of the questions that we always get is what is actually Ventry? Because the reason we started actually engaging in conversation and dialogue on this particular topic of spare parts management is we've seen that over the last 10 years, the solar industry has really seen an exponential growth, where owners or operators that were managing maybe a few hundred megawatts maybe a decade ago or even a few years ago are suddenly managing hundreds of sites in the gigawatts in portfolio. So just as how NovaSource has been through the whole phase 1 and phase 2 approach, there are lots of attendees and companies here actually on this webinar that that have actually been through this journey or are going through this journey at this very moment. So the purpose of this webinar actually is to share some of the best practices, from the likes of NovaSource, that's the biggest, to the future, the next one coming up, which would be one of the smallest players that we work with today in the US. That would be a very interesting perspective as well. So the next slide is going to be about what is actually Ventry. So Ventry, we are a recent startup. So we launched our first beta solution earlier this year. It was in March this year. And since then we have, we've been quickly deploying the solution across multiple industries, particularly within the life sciences sector, the high-tech enterprise computing vertical, and the energy and the renewables energy vertical. In basically helping these enterprises to manage their field stock and inventory levels in the field. So one of the most common questions we get asked is, what's the difference between an SAP ERP solution or a solution from IBM or Oracle or even Microsoft Dynamics? And one of the key differences that we talk about is coming back to Tim's reference to the Aston Martin. I'm going to compare it, since I'm based in Europe, I'm going to compare it to another manufacturer like a BMW. If you go to a BMW garage and ask for a spare tire, just for a spare tire alone, the first question they'll ask you is, okay, so do you own a BMW, or are you going to buy a car through us? And this is a very big difference in the sense that Ventry has been designed to work for enterprises that have an ERP solution in place or may not have an ERP solution in place. So this is where the solar vertical becomes so interesting, because you have the NovaSources of the world that do have an ERP solution or a CMMS solution in place, to the smallest of the companies, which may be a 5-man or a 10-man company, maybe doing amazing work in their local communities, but do not have any existing digital infrastructure in place. And that's where Ventry actually has been designed for as well. So it's meant to be worked as a standalone solution, or as an integrated solution to an ERP solution, where it actually becomes an extension of your ERP solution, but on a much more intuitive and a simplified manner. Something also important to understand is that Ventry was designed as out of the box, which basically scales with your business in the sense that if you have 100 sites or 1,000 sites, it doesn't really matter because we are it's a SaaS solution, which means it's a cloud-based infrastructure where basically the moment you integrate it with an ERP solution, it works everywhere. Or if you have it as a standalone solution as well, you can deploy it pretty much anywhere. The other thing which we see a lot, especially everywhere from Australia to Malaysia to Chile or the US, is that it doesn't matter if you're a developing country or a developed country. Many of the large solar sites and infrastructures are built in remote locations, or let's say are meant to to provide energy and power into a certain city, but may not have the best coverage. So this is something that we've seen from the healthcare sector, where parts and equipment and medical devices were being stored in basements of hospitals. So this was something which was very much important for our solution to be able to work online and offline, where essentially the moment the person is connected into the network or Wi-Fi network on the site, the system just synchronizes with the cloud, and the moment it loses connection, it uses the last synchronization on the device itself to basically update. And this is quite a game changer, especially for field engineers, where you want to make sure that engineers or field staff are not demotivated because the solution has suddenly gone offline and they're back into their into working in a rudimentary approach on pen and paper. So that's something important. The other thing that we've also learned through the life sciences and the high-tech enterprise computing sector is that many of the providers actually work with in-house engineers, but also subcontractors. So even if you may be an O&M player or an asset manager doing your own O&M, we've seen models where in some locations, depending on the scale of your business and the number of sites in your portfolio, you may work with in-house engineers in some locations, whereas with subcontractors in another location. But that should not define how you deploy the solution. So this was something quite important to consider as well in the solution design phase when we rolled out Ventry. And finally, I think, Josh, you touched on it, which is what we call as the minimum quantity levels that you want to maintain in your sites. Something that we're really working very hard towards with the solution is that the industry needs a solution where similar to the high-tech enterprise computing and medical devices sector, you want to be able to maintain a certain level of stock in these sites. And what ends up happening is that the number of times we've spoken to players in the market who actually say, I think we have too much stock in the field, and we may never even end up using it. Whereas we believe that, I think Tim and Josh, you covered it, where you want to be able to maintain a certain level of stock and cadence and understand that cadence. What are you using? How much of it are you using? So that you can either do replenishments, rebalancing, redistribution of stock across your sites, or even potentially resell the stock to other customers in the area that may be actually in need for that solution, and kind of liquidate some of your assets that are in the field that you may never end up using, and just add it into your bottom line of your P&L. The other thing also what is quite important is that SaaS framework. We see that a 5-man or a 10-man company can own 100+ locations that they might be servicing. A typical ERP solution is much more expensive and complex to deploy. Whereas the way Ventry was designed is that if you're a 5-man or a 10-man company, so we have a customer, for example, in Colorado, where where they are literally a 5 or a 10-man business, O&M business, and they are able to deploy and manage it across 50 locations, which is super interesting to think about. But then you also have a German account that we work with that is present in 20 countries using the solution. And that's where you can have 88 users across 100 locations. And that's something which is very different from an ERP perspective to deploy. Going on to the next slide. So here's an example of a example of let's say several locations belonging to one asset manager in Spain. They're a global asset manager. They have 153 sites in the country, which means that they have they're storing parts at 153 locations. And this is something, Tim, you talked about, where you have these islands of information, but if you deploy Ventry in phase one, you're able to literally get that overview of what's actually happening in all of these locations, which becomes super interesting because then you're able to look at, okay, what do you have excess of? What do you, how do you rebalance? How do you replenish? And how do you really go into an assessment of your entire supply chain and build a strategic vendor strategy? So you don't end up with maybe 4,000 vendors that you're working with, but really strategize based on the type of equipment and materials you want to use. And then finally, you can start looking at that smart ecosystem in your digitization or your digital transformation journey, where you could potentially start connecting things like logistics providers who are able to give you that SLA coverage between 2 hours or 4 hours or 8 hours. If you do want to get to that level, you can even sell your stock online on an online marketplace. You can start, ordering materials to manufacturers, order RMA processes with repair vendors, and so on. But also on the other side, integrate it with monitoring systems or CMMS systems or ERP systems that we talked about, especially if you have a pretty significant portfolio out there which requires an ERP or a CMMS solution. Now, what we do see in the market as a trend, the more we start rolling out the solution, is that more and more asset managers and O&Ms are standardizing their monitoring systems. They're deploying a CMMS system or an ERP system because it is a significant investment. But if that's the level you're going to at some point in the future, this is the way to think about on building that vision. And this is what we are trying to move towards as well. Here's an example of our collaboration with DHL. We covered this slide in the last webinar, where something that DHL is also interested in looking at is how do you provide an asset-light organization? How do you enable an asset-light O&M or an asset management organization from an owner and operator perspective, but at the same time, use existing locations in order to give that better coverage, tying into what NovaSource Josh was talking about with the hub spoke and a distributed inventory management system. Now, NovaSource is able to do that today because of the sheer scale of your business. But this is something that especially the small to medium-sized enterprises could look at as an alternative. And this is not to advertise DHL services. It's just to put it out there and say that there are companies out there that are very much keen on looking into their spare parts business, because this is their bread and butter for multiple other industries like medical devices, high-tech enterprise computing, and so on. So with that, I would like to move towards our Q&A session. I'm just looking at the time here. So it is 4:15, which is good timing. So let's start cracking on with a few questions. So I'm going to read the first question that's come in from Chelsea. So how can we as suppliers assist with educating owners, operators on what patterns we see in regards to high failure components, how to prepare the failure before it occurs? Josh, do you want to go first?
Yeah, happy to. I think for me, it comes back to mapping that part to the assets it goes into. Some suppliers can do this pretty well. And from that perspective, it is kind of a collaboration. I think it's getting with the owners, operators that are ordering the part, looking at how much they've ordered, maybe giving them insight into what you're seeing across your entire sales channel, and giving them recommendations based upon their asset, the size of that asset in their fleet. We're trying to do this at NovaSource today. I call it trusted advisor. And it's a communication. It's a sharing of data. I don't know, Vishal, maybe that's something you can look at in the enterprise system in the future. right? But the sharing of data so that we can all benefit from having the right MOQs on hand in preparation for failures. Today, I think it's today for me it's conversations, and giving advice and what we're seeing.
Tim, would you like to share your feedback and experience on this? Because you've been in the industry for quite some time as well.
Hang on, can you hear me? I think Josh hit on a very interesting point about sharing information. And so one of the things I'm asked to do sometimes is Tim, can you give me analysis of what we can expect, what the predicted inverter failure points? And so you think, yeah, there must be some work on that. And you try researching on the internet. Inverters have been around a long time. They've been failing a long time. But because we have these islands of information, it's very difficult to assess that. And so take the cooling fan. How often do we need to replace a cooling fan? Well, if you have local information and over the past 2 years, I've had to replace these parts, but actually finding predictive models of what we can expect to failure, what points we can expect failure is very, very difficult. And it's only now as we start to go in this digitized process. So if you ask this question 2 or 3 times, years time, Josh will have some data, I'll have some data, and we'll be able to say, well, we can look back and say these are the pinch points. But we're not actually at that point yet. We're at this strange analog state where that information is written down in site logbook. So we have all this information, but it's not centrally accessible. And this is the kind of pinch point that we're at. So I think unfortunately, we haven't got that data yet. Or if people have got it, they're not actually sharing it.
There was another question that came in earlier today when I was reaching out to some of the people to ask questions prior to the webinar. So there's one question that came in from Jeremy, who is with Canadian Solar. So he says, how is the industry aiming to expedite and make the receiving of spare parts at the site more efficient? Josh?
Well, so you can control the trucks that deliver it. NovaSource even hasn't gone to the size where that's economical for us. So there's only so much control you can have when you're shipping it out, DHL, UPS, FedEx, or even on LTL carriers. I say that, I always go back to what's the touch point for the technician? How long does it take them to put that asset into inventory? For me, it is like if the app can do it itself, if the system can do it itself, they just have to scan a barcode. That is, a few less touches, a few less screens that technician has to go into. That's increased wrench time, right? So that's a more efficient technician. So again, it gets back to the intuitive nature of the app. It has to be easy for the field to use. It has to be intuitive so that as you scale, you're not having to redo training. It has to be flexible to adapt to your operational changes, because ultimately this whole game is about increasing technician wrench time. And we have to take the onerous, job of managing spare parts out of that equation as much as possible.
Got it. Thanks, Josh. Tim, would you like to add anything to that?
Yeah, I think one of the other key factors is, if you remember, I did the entity life history of a spare part. So one of the key things really, and I know Josh has touched on this before, is understanding the impact your spare part has on the plant and what's the availability of that spare part. So some parts are always going to be difficult to get hold of. There's always going to be that 2 to 3 weeks lead in. And if they catch you out, it's because maybe you haven't anticipated it properly. So one of the key things in the digitization process is to look at each spare part and saying, what impact does this have on the plant? So take an MC4 connector. Your plant isn't going to fail because an MC4 connector's burnt out, and yet there'll be hundreds of them on site. But there could be a particular type of fuse, a heat exchanger, some particular component that has a lead-in time. So the important thing is to know where those spare parts are. Maybe you have one on another site. So NovaSource have a central inventory, so they have one site they need this particular component. They can source it from one of their other warehouses and they can get it onto site. A smaller organization may have half a dozen plants, but they could still have shared resources in terms of those spare parts. So the easiest answer is that sometimes you have to accept that's part of the condition of that spare part. There's going to be a lead time, and you kind of plan for that rather than try and get caught out of needing a part that you suddenly realize isn't immediately available.
Got it. Thanks, Tim. There was another question that came in from Juan, who's with Uptime Solar. I think they're based in Texas. So the question is, he's interested in knowing how easy it is for the field members to have inventory updated when parts are received and parts are used. I think, Josh, when you and we spoke for the first time, you did mention that this was a major headache for you, or has been at least. Could you perhaps answer Juan's question?
Yeah. So MOQs, reorder points, we've been doing that for a long time. I think it comes, it's when you look at the way we assess it, it's much like manufacturing. The difficult thing we always had at First Solar, and I'll say this openly, is our system wasn't live, right? It would had a 24-hour gap when we would see consumptions. Again, that offline online challenge. It was really technicians taking down their notes and digitizing them at the end of their workday, and then even our demand planning system, we'd run it weekly. Now that worked, and we adjusted our lead times. I mean, you can get around these problems by adjusting mid-max lead times to account for the 7-day gaps. But the best thing is just having a live system, right? The technician does the work. They put in the system. They're not taking a note down. They're not, clocking out, getting off the field, and then putting their work notes into work orders. It's having a live system for them right there to, put the inventory consumption in as they actually install the part.
Great.
And likewise, I'll add, likewise, when they pull the old part out, if when they scroll through the inventory and we can see that part can be refurbished, they can put that part into damage to be repaired status.
Got it. I see a question that's come in from. Sorry, Tim, I didn't want to take over. Would you like to add anything there? Please, just feel free to step in.
No. Yeah, no, there's not much more I can add.
Okay.
I mean, cool. We've been on lots of plants where there is no phone reception, and so if you can't work offline, it's going to be. No, it's not impossible, but it's an unnecessary lag.
Yeah. Got it. So Sebastian, he's just put in a question on the chat function here. So are you planning to revise current stock levels across the warehouses based on current mounting supply side risks? Josh?
What supply side risks? I don't know what you're talking about. Yeah, a demand planning system can only look back at the data you have, right? So it's not going to predict future lead times. For our supply chain organization, it's our commodity management buyers being very close with our key OEMs, our key suppliers, understanding what they're seeing from their manufacturers. And then, we either make decisions if it's going to be an endemic issue. I will say semiconductors are going to be an endemic issue. We adjust our mid-max lead times in the system to account for that. So we're ordering parts well in advance. That would be impacted by that. Control boards, PCBs, PCBAs, communication nodes, even some inverter fans. They're smart. Then they've got chips in them and they're being affected. If it's going to be a temporary slowdown, we do what we call ad hoc buys. So we'll preemptively adjust our inventory levels by doing a one-off order. But again, that's really if it's going to be a short-term. We're seeing a short-term supply side risk. And it's not even just supply, it's like if there's other demand popping up, it can happen really quickly, and we don't want to wait for the demand planning system to catch up.
Thanks, Josh. Tim?
Not much more I can add to that. That's definite supply chain question. Okay.
Great. So there's another question that's come in from Tim or Josh, from Osman Siddiqui. How are you dealing so I think the first question was for Tim, actually. So how are you dealing specifically with string inverters as spares? RMAs can take anywhere between 2 to 4 weeks. So do you keep spares to react faster?
Generally, yes. Part of a standard spares package for string inverters would be to have, depending on the size of the project, at least 2 or 3 spare inverters.
Josh?
Yeah, we call them hot swaps. Make sure you got some spares there, swap them in. it should cover you during the RMA process.
Okay. So while we wait for a few more questions to come in on the chat box, so there was another question from Juan from Uptime Solar, saying he's also interested in knowing if there are any kind of reports that can be used to track how many parts are used per month, or even if there are best practices in place. Or even if system keeps track on the order. Yeah. So basically, so firstly, what kind of best practices would you recommend, Josh and Tim, in terms of understanding how your stock cadence utilization, or stock utilization cadence, sorry, and if there are any things if you've looked at historically to understand, the lead times for these parts. Josh?
Yeah, I'll start with that. So this gets to the integrated systems, right? The ERP system that we're buying parts in, it's going to show live lead times. You gotta make sure buyers keep those lead times accurate. If you can get a supplier access into your ERP system to manage their orders, that's even better, right? Especially if you're dealing with 10,000 orders a year. That's going to give you your accurate, lead times, your averages and maxes for your demand planning system. And then from a consumption perspective, that is the boots on the ground consuming out the inventory in work orders. And I'll add too, I would say rational cycle counts. In some areas we do monthly, some areas we do quarterlies. Our distribution centers counted monthly. Some sites are small, we do quarterly. Sometimes we do once a year, depends on how much inventory they have at that site. And all that together, it should be coming into one system, your inventory management system, so that you can pull your actual consumption usage and make those adjustments for the next year orders as needed.
Tim?
Yeah, it's very much the same as Josh is saying. I mean, what we're talking about is understanding mean time between failures as well, so you can predict over the next few years what your stock's likely to be, to also identify potential problems and look for trends as well, serial failures, that kind of stuff you can do. It's a very straightforward report. Once you've got that information in the system of what you're actually consuming, what the parts are, a little bit about the asset, what the part is for, then it's very easy to run not complicated reports, but enough to be able to predict what you're going to need over the next few years, which is the most critical thing. The other thing you have to think about is end of life of products. So some of these inverters are going to be in the field for 25 years. Maybe those spare parts won't be available for the next 25 years. So if you've got a particular component that you have to replace every year, someone has to plan ahead so that you've still got those parts in 25 years' time.
So a question perhaps from my side, and perhaps this is more for Josh, or Tim as well, is what in an industry where, for instance, certain components are actually even phased out by manufacturers, let's say every couple of years, and new models or more efficient models that are introduced. How do you keep track of, for example, for an older plant, how do you work on equipment compatibility? So that because if modules, if you're using older modules but newer inverters coming in or newer electrical components coming in, how do you keep track and how much effort actually is spent on better understanding on this equipment compatibility matrix?
Matrix is a really good way of describing it. I'd say time. I spend a decent amount of time mapping what I call parent-child relationships, right? What asset uses which children? And by the way, as we've done this, and we've done it across most of our large asset bases, we find many children have multiple parents, sometimes up to 20, right? Which is great to see. It's great to see when OEMs are using the same components, because that means we can better utilize and lower our inventory amounts to cover a broader asset base. But that's the holy grail, is you got to know what parts are going into what assets. That's how you know how much to stock. You add to that, as Tim mentioned, like you look at your work orders, what parts were being used in which work orders, and all of that goes into what parts, what we call A or B parts, do we need to have on hand. And as far as end of life, it really gets down to so for that parent child, you look at the next product, a new power supply, a new DG key, node module. Is it compatible? We use internal engineering as well as external experts to help with that, and a lot of collaboration with the OEMs as well, right? They design the product, they know if it's compatible. And so it's an ecosystem that keeps these parts alive. When there is a last time buy, you work very closely with your clients to make sure that they understand that if we don't do this bulk buy now, they may well run out of parts.
Tim?
I mean, it's absolutely right. I think it's a bigger problem with central inverters. The interesting thing is, as we see more string inverters being deployed, I think they will change more quickly. So there'll be new versions. But string inverters are kind of like solar modules in that, surprisingly, it's easier to find a compatible string inverter to replace an out of stock one. So I think this kind of problem will be more for the large legacy central inverters. And I think it's going to be a big problem in 15 years' time. But also, as Josh said, when you start looking inside these boxes, that everything isn't in there that's made by TMEC, for example. In there will be a Delta fan. Delta fan is an OEM component, and there's lots of other OEM components with the right access and the right support. You can find compatible components. And so in 20 years' time, you'll see quite bastardized inverters, but they'll still be working because the technology behind an inverter isn't as complicated as it looks. And on the solar panel and on the string inverter side, then swapping those out, I think, is much easier and isn't such a great problem.
Got it. So just looking at the clock, so we are almost at the hour. So maybe the last question coming in from Stefan. I think so. Stefan from Second Sol, based out of Germany. What about transformers? I think we've talked about central inverters, that we see that there will be some issues in the next, for the older sites or sites, let's say 15 years from now. But perhaps your thoughts and feedback on transformer issues.
Yeah, for large step-up transformers that we see commonly in UPP or utility size power plants, we would, depending on the size of the project, we'd recommend buying one spare unit for every type you have. Hopefully you only have one type, but there's always that odd block that has that one-off transformer. From there, you can use that unit as a hot swap. So, you have a transformer fail. If it's a catastrophic failure, you can swap in that spare transformer into place and then have a very good network of reliable transformer refurbishment shops that can repair that failed transformer, and that failed transformer then comes back to your site or your storage location as the next spare. So from a transformer perspective, the nice thing is they're not overly complex to rebuild, and I've seen transformers on fire that we've successfully been able to recase, rebuild, and put back into service. And we do trend them. We do oil samples, and even those refurbished transformers, if you work with reputable shops, it's not always the lowest cost, right? If you work with those reputable shops, those refurbished transformers will trend from an oil sampling perspective just as if they were new. Great.
Well, just looking at the time, it's 4:34 here, so we are a bit over. And yeah, I don't know, Tim, do you have any last closing message for the people? We still have around 20 participants on the call with us.
No, I think only just my comment at the beginning, the whole process of digitization really isn't new. It's been happening in lots of industries for 20 odd years. For some reason, the solar industry is slightly behind the curve. And and which is why there's not a lot of data out there, as we talked about earlier on, for finding out where things are going wrong, what the faults are. But yes, it's changing very rapidly, and and I think we're moving away from this boots on the ground. We need to get to condition-based predictive maintenance, and using some of this technology is a way of actually reducing the OPEX cost for plants by managing them more efficiently. I'm not spending time doing inspections and stuff that doesn't really need inspecting. Yeah.
Josh, what about yourself?
Nothing more to add to Tim's comments.
You know, just one last comment just for everybody is that, you know, it was almost a breath of fresh air when I came across Josh maybe around 5 months ago, because actually, Josh, you were one of the first persons I came across that actually had a supply chain management title in you know, working within the solar industry. Now, you know, since our introduction, I've actually come across, I think, 2 more people in the whole industry that, I mean, and I'm not saying I know everybody, but it is a rare position in a company. And I think it's probably because of the scale of NovaSource that people have understood and recognized and accepted that if supply chain is not under control for a size with a significant impact that NovaSource has, that, you know, it is an important function to have. And I do think over the years to come that more and more companies will have kind of a 50% FTE allocation, or even a full FTE allocation into managing the supply chain, you know, for their sizes of portfolio, whether you're an O&M, EPC, or an asset manager. I think, and that's the trend I think is going to happen more and more over the course of the next coming years. So with that, I really appreciate your time, Josh. You know, it means a lot. I know that you were very excited to spend time on this, and that means a lot to us. Tim, same for yourself as well. I hope that the presentation and this webinar was beneficial to our attendees. So thank you again, and we will be sharing the recording on social media over the next couple of weeks. As soon as it's available, I will send out a message to everyone who's attended the webinar. Thanks again.